So hey guys, welcome to Deep Dive Coding. In the previous video I explained this part. This will be the linear search part, and you can do that way also, and if even it is also optimized way to do it, that would be the binary search. Why? Because it is the sorted array, as the questions is given that letters array is sorted in non-decreasing way. So you can non-decreasing way, so you can apply the binary search. Binary search to search whether that element exists or not. So what you can do, so I will first let's take an example over here. So letters are given something like this way, that first one element is A, let's say this is B, and C, D, E. Okay, and no, let's modify this a little bit. So let's take an example of first A, B, and let's say F, G, and H, and target, let's say given character as you can say D. So we want to find smallest character which is greater than D lexicographically. So any elements in this value, because this is the less than B and these are elements are greater than B. So what you can do, well, apply the binary search. So 0, 1, 2, 3, 4. Now let's take a low pointer at the 0 over here, it's low, and let's take a high pointer that would be over last index. This will be the high pointer that at the index of 4. Now calculate the mid pointer from this low and high. So this will be the done using the formula low plus high minus low by 2. Why I am using these things? Because this is a standard formula to avoid the overflow. So basically you can also write this way, that low plus you can also write this also, low plus high by 2. This also is a valid formula, but in some situations it is overflow, because low and high is we are adding these things. To avoid that, we always use the high minus low by 2, but over here it did not create any problems, as low and high also is small. So you can just simplify this formula. It will be give you the same result as the above one, that will be the high minus low divided by 2. Okay, so if you simplify this one, so you can take the 2 as common, then 2 times of low plus high minus low. So it will be give as it will be simplified as low plus high divided by 2. So this is the same formula. You can say mid equal to, this is the same formula. Now calculate the mid for the first one. That would be like you can 0 plus 4 divided by 2, and it will give you the 0. Sorry, it will give you this 2. So you check that second positions. There are second positions have this element, second index, the F element, and you check that mid element. Let's say this is the letters of mid. If it is greater than the target, then it's a valid answer. That means we update our answer as minimum of answer comma letters of mid. What it mean? That means if we are in the any positions which is like greater than target, that means L of mid over here it's F and it is greater than the D, so it's a valid answer. So in the answers we store F as an answer for temporary answer. And in now if this conditions is valid, then we try to find the lowest lower minimum. So we change the high pointer as mid minus 1. That means we reduce the space by half. Okay, so now it will be let's write properly. Okay, so now high pointer go this one, this way. So mid, this will be the mid. At mid minus 1, this will pointing to the high. Now if you again compute the 0 plus 1 divided by 2, and it will give you 0 because it is done the integer divisions. So now mid pointer will point it over here, and if you check with this that whether letters of mid, is it greater than target, it will give you the false. When it is give you false, we just update the low equal to mid, low equal to mid plus 1. So now low also go to the next. That means low also go to the index 1. So again if you check low over here, now low equal to 1 and high equal to also 1. So if you find the mid again, it will give you 1, and you check this is the mid right now. Let's erase for this one. Okay, and yeah, so now you erase this one, and mid is over here. Now mid is updated, and you again check is the mid element is greater than the target. No, it's not greater than. So what you do, you again increase the low pointer. So low pointer mid plus 1, that will go, low goes to the over here, but still high is the 1 positions, like first index. So right now low value equal to 2 and high value equal to 1, and this is a invalid case. So we exit from the loop in these situations, because low should always less than equal to high. This is the main conditions to exit. And so when we exit these conditions, we have either we have already stored the answers array as valid answers, otherwise are dummy answers. If it is dummy, if it is not updated answers, then we can simply return the -1, because it is not sorry, not -1, we return the first element, otherwise we just return the answer. Now let's come into the coding part. Let's give me time to erase this thing. Okay, now come into the coding part. How you can code some similar, like okay, so as I already said, we taken low pointer and also high pointer. Low pointer is pointing to at the 0th positions, and high pointer is pointing to the last element of the letters. Now we take a max characters, that you can say 1 plus z. What it mean? It is the next character after the z small, that will be the this character. Let's say smaller a b c up to dot 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 z, and this character we are taking as a max character, because we only deal with a to z smaller case English letter. Now we initialize the answer as maximum max characters, so that we get the minimum of it. And now go into the while loop conditions, and the conditions is low less than equal to high. When the conditions low greater than high, it will exit from the loop. This will be the main conditions to exit. Now we calculate the mid pointer, as I already said, low plus high minus low by 2. This will calculate the mid, and if the target character is less than letters of mid, that means this is the greater than the target character. So this can be a valid answer. So we update the answer equal to minimum of answer comma letters of mid. And as this is also a valid answers, and we want the smallest valid answers, so what we do, we update the high pointer as mid minus 1. And if it is not true, that means target is greater than the letters of mid, then we simply increase the low so that we can find the target. That would be the low equal to mid plus 1. And at last we just simply check whether answer is still max character. If it is still max character, that means these portions is not executed even once. That means there is no valid answers in the array which is greater than, lexicographically greater than the target. So we just return the first characters of the letters array, and at last we just return the answer. So this will reduce the time complexity, as we only go to the, like, we reduce the space to search. So it will give you the, in each time it will reduce to by the half of the space. So either we, let's say you are in the low over here and high pointer over here, and you calculate mid over here, and either you calculate the mid whether it is satisfying or not. According to, we either search space updated in mid to high, otherwise search space updated to the low to mid. So this way you just reduce the space each time half. So it will give you the time complexity as big of log n time complexity, and it is efficient from the previous approach. As the characters, like letters, is already sorted, we can apply the binary search. So it will give you the log n time complexity, and we are taking low and high as in space, that, and also max character and answer, these are the constant space. So it will be the big of 1 space complexity. Thank you.